Okay, I think we'll go ahead and get started. It looks like we have a lot of participants in a really active group. And so before leaving you to the speakers, I just want to introduce ISGAN a little bit. My name is Daniel Webben. I'm the manager of the communications working group of ISGAN, who is the host of your webinar today. ISGAN is of course short for the International Smart Grid Action Network. We are a technology collaboration program of the International Energy Agency. ISGAN is also an initiative from the Clean Energy Ministerial that was established in 2011. And our goal is to create a strategic platform to support high-level government attention and action around the accelerated development and deployment of smarter and cleaner electricity grids. We have 27 contracting parties from all over the world, and we are represented by operating agents, work groups, task leaders, and national experts. These are some of our working groups, and our vision is to accelerate progress on key aspects of smart grid policy, technology, and investment by participation, voluntary participation in various projects and programs like these webinars. We have 5 kind of principal areas of our activities: policy standards and regulations, finance and business models, technology system development, workforce skills and knowledge, and users and consumer engagement. So as part of these activities, we are trying to facilitate dynamic knowledge sharing, technical assistance, peer review, and project coordination among all the different contracting parties. The value that ISGAN is really trying to bring depends upon conferences and workshops and webinars like this. We also help create policy and technology briefs, host discussions and publish technical papers, and also write and release casebooks. So with ISGAN, we have these virtual learning, and we're trying to foster a community for this, continuous development of technical skills, but also policy sharing and smart grid development. And so the Learning Academy is proposed as a set of e-learning and reading modules that deal with the entire value chain of smart grid development. And so with that short introduction, we're now going to turn it over to the speakers about TSO and DSO coordination today. Thanks so much.
And thank you for the introduction, and also welcome from my side to our exchange in TSO-DSO coordination. My name is Clara Kuhn, and I am part of the project team from RWTH Aachen. We are contributing to ISGAN's Working Group 6. The aim of our contribution to ISGAN as German representatives is to support the national and international exchange in the field of TSO-DSO coordination. With the help of ISGAN, we enable the accessibility of scientific results for all stakeholders and improve the needed cooperation between TSOs and DSOs. During this webinar, representatives of 4 projects will give insights into current and possible future designs of a cross-level network operation and will highlight resulting challenges. The focus is on the 5 topics you can see on the right: the coordination task, the organization of the access to resources, the involved voltage levels, the proposed market design, and the data exchange. Therefore, I would like to welcome our speakers who will give insights into the 4 projects DARE, OneNet, Redispatch 3.0, and CoordiNet. I would now like to hand over to Julia Strahlhoff from the German DSO Netze BW, who will introduce the project DARE.
Yeah, thank you, Clara. I'm shortly introducing myself. I'm Julia Strahlhoff. I'm working at the German DSO Netze BW in the German state of Baden-Württemberg. And I'm working as a product owner for the IT project DARE. And now I will present what our project is about and what our aims are. So you can go to the first slide. DARE is a cooperative project between the DSO NetCBW, where I'm working at, and the transmission system operator Transnet BW. And yeah, we're working together on DARE, which means data exchange and redispatch. So DARE is an IT solution for grid-based coordination of TSOs and DSOs in the context of Redispatch 2.0. DARE is a sorry. Shortly, the Redispatch 2.0 has arisen from the German law NABEG, which means Netzausbaubeschleunigungsgesetz. It's especially aims at replacing the reactive curtailment of fluctuating energy resources by proactive feed-in management. So yeah, the old Redispatch 1.0 processes, which only concerned the TSOs in the past for regulating the bigger power plants, are now further developed, because grid bottlenecks are increasingly occurring at the lower voltage levels as well. And here, small-scale flexibilities are available that also can be used to eliminate those bottlenecks. The mentioned law says that all flexible energy resources which are bigger than 100 kilowatt are concerned by Redispatch 2.0. So the grid operators from each voltage level are allowed to use those decentral energy resources either in their own grid or in subordinated or neighbor grids for solving their congestion management. And this makes it necessary to have a good coordination between TSOs and DSOs of different voltage levels. And the DARE platform supports this coordination task by processing and forwarding data from different actors. For example, the schedules of flexible resources by resource providers or by the connection grid operators, or the grid congestion forecast by grid operators. And the communication by the with the resource providers is German-wide, organized via Connect Plus. It's like a basic solution for Redispatch 2.0 and the single point of contact for the resource providers or aggregators of the energy resources which are part of Redispatch 2.0. And also the data exchange with other grid operators which are outside of DARE is also realized via Connect Plus. So the special function of DARE is that it has some additional functions as a service for the grid operators. For example, the aggregation of data and the optimization and energy balancing in context of Redispatch 2.0 processes. But I will explain more on it later on. You can go to the next slide. So the base of the mentioned DARE optimization is cross-grid congestion management by cost minimization. That means the activation of energy resources for Redispatch 2.0 takes place with the aim of minimal costs with the highest effect on a grid congestion. For this, DARE coordinates the DSO and TSO demands. And first it starts with the DSO demands up to high voltage level. The grid restrictions of the subordinated DSOs are considered for the calculation of the aggregated flexibility potentials for the TSOs. So the TSO activates aggregated resource clusters in the DARE network, and DARE disaggregates the TSO demands for the optimization problem. And the redispatch potentials inside DARE network are disposable for the general TSO tools. And yeah, it's important to say that the activation of energy resources in Dare happens non-discriminating inside and outside of the Dare network. And maybe it was a bit fast, but I think you will understand it better on the next slides. So yeah, the need for the coordination is caused either by bottleneck in the transmission system and or in the distribution system. So it can be a central or a local problem. And the target of Dare is the overall elimination of grid congestions by cross-voltage coordination of redispatch needs and potentials. So the coordinate redispatch use across multiple grid levels is the aim to reduce redispatch costs. And Dare has no direct access to the resources. The resources are controlled either by the resource provider or by the DSO himself. This depends on the technical steerability of the energy resource. So it's important Dare does not execute the steering of the resources. It only sends an activation document with the calculated schedule of the energy resource. So like a kind of instruction for the operator for the right schedule of the energy resource. The question for the utilized market is a bit difficult because strictly speaking, there's no real flexibility market which is concerned. So the congestion management and the activation of resources is executed according to the specifications of the BNetzA. It's the German regulatory agency. And there's only an interaction with the energy market for the procurement of energy for the energy balancing after after a redispatch activation has taken place. And this special process is not part of Dare. So it's after the Dare processes have finished. I can explain a bit more detail on the next slide. So the product Dare is exclusively developed for Redispatch 2.0 processes. It's an extremely standardized product defined by the legal and regulatory requirements. And as I said before, the implemented processes and the data formats that are based on the definitions by the regulatory agency BNetzA and by the Energy Industry Association BDEW. It's they developed the processes for the Redispatch 2.0 and also the data formats that have to be used by all participants in Germany for these processes. And for this, the TSOs and the DSOs are forced by law to coordinate their demands and the use of flexibility in compliance with those certain regulations. We have a very regulated market design. So we have no competitive selection mechanism for solving the grid congestions, but only a regulatory cost-based selection mechanism. And as I said, there's no real market. There's also no market operator in this sense. I could only mention that Connect Plus has a special role in those processes because, as I mentioned in the beginning, Connect Plus is a German-wide actor in the context of Redispatch 2.0, but not in the sense of a market operator. It's a basic solution for the data exchange in the context of Redispatch 2.0 for all grid operators, and the single point of contact for the resource providers. And Dare communicates with Connect Plus as a service provider for the grid operators that use Dare. So Dare is an IT solution from grid operators, Transnet BW and NetCBW, for other grid operators. So we use this tool ourselves and offer it to other grid operators, especially in Baden-Württemberg. And yeah, we do not pursue an intention to make a profit, because we just want to have a yeah, stable and secure net and yeah, working processes for Redispatch 2.0 and yeah, in our system. So yeah, there are also other IT solutions in Germany which offer services for Redispatch 2.0 to grid operators. So yeah, you could say the product itself is kind of competitive, because yeah, the grid operators could also use another tool than Dare. And yeah, but yeah, as I said before, there's no real flexibility market. That's how I understood the question. And the next slide, I could explain a bit more detailed which processes and data exchange in detail are executed by Dare and by the users of Dare. And yeah, first, some technical facts for all our processes. There's an exchange of XML documents implemented. This was yeah, caused by the regulations of the BDEW. And we have interfaces and a cloud provider that meet the technical and security standards which are required by BDEW, BNetzA, and the German Institute for IT Security. And we offer a data exchange via different interfaces, for example, via REST API, email AS2, and SFTP. And we also offer a graphical web user interface. And yeah, the process begins on the left side here in the picture with the master data. So the master data of the energy resources is provided by the resource providers and completed by the grid operators. And especially in Dare, we use for the subsequent processes a simplified grid model, which is offered by provided by the DSOs. And yeah, on this grid model, we can build up our yeah, subsequent processes. And yeah, following the master data, the planned value-based rolling processes in Dare are running. And it begins with the yeah, forecast for resource schedules. So the grid operators or the resource providers, they create forecasts for the renewable energy plants and yeah, the grid operators in their own grid, and send them as planning data to Dare. The content of this planning data is a schedule of the energy resource, and yeah, important, the flexibility potential of the resource to steer it. And the function of one function of Dare is to aggregate the planning data of the resources across the grid according on the effect on specific nodes in the grid, so that the grid operators can see which is the effect of the of all energy resources on yeah, special nodes in the grid, and they can perform a grid condition analysis. And yeah, as a result, the grid operators report to Dare the potential bottlenecks in their own network in a form of a congestion forecast. And with this information, the Dare core process begins. That means the Dare optimization performs the asset selection. So they, yeah, specific energy resources are selected to resolve the network congestion. And the input data is, as I said, the resource planning data and the grid congestion forecasts. And yeah, the costs of the resources are taken into account. Yeah, as a result, Dare creates and sends activation documents, which I said before is the instruction for the operators to steer the resources. And after this, Dare triggers the dispatch of the schedule to the TSO systems, and this triggers the execution of energy balancing. And the energy balancing is also a service from Dare to the grid operators, which have to execute the redispatch processes. To sum up, one function of Dare is to realize the data exchange for the Redispatch 2.0 processes. And in addition, Dare offers further functionalities, which relieves grid operators of the task of selecting energy resources for their congestion management, and especially also the balancing and energetic compensation after an activation of a resource for the redispatch has taken place. Yes, that was I wanted to tell you. And I don't know if you have some questions, I can try to answer.
I think we're doing the Q&A session after all the presentations.
Okay.
So thank you very much for the German perspective on how the TSO-DSO coordination is already done or can already be done in Germany. Now we are handing over to a more international research project, which is OneNet. So I'm handing over to the speakers presenting OneNet.
Thank you, Clara. Good afternoon, everyone. My name is Gwen from Vito Energyville, and together with Ferdinando from ENG and Matteo from Comillas, we will briefly explain what OneNet is doing. So next slide, please. Yeah, before we get really into the questions, we will just briefly present OneNet. So OneNet is one network for Europe, and the vision of OneNet is to create a fully replicable and scalable architecture to operate the European electrical system as a single system, coordinate a variety of markets, and allow universal stakeholder participation. And we do that based on 3 pillars. So the first pillar is the definition of a common market design for Europe. The second pillar is the definition of a common IT architecture and IT interfaces. And then we also have the verification of the proposed solutions in large field tests. So that's in demos. Next slide, please.
Okay, good afternoon. This is Matteo, and well, I will answer to the question, how is the coordination task defined within the OneNet project? Actually, in the OneNet project, we formalized that the interactions between the electricity actors as TSO, DSO, and flexible service providers can be modeled in 2 ways: in market-based coordination and technical-based coordination. In market-based coordination, we have that actors interact by means of a market architecture, which includes the interaction with the market operator and the market platform. While in the technical based coordination, we have that the actors interact by means of a technical architecture, which complexity may vary. These 2 types of coordination are not exclusive, so we have a situation in which the coordination is addressed by means of both of them. And thanks to this classification, we are able to describe all kinds of coordination that we observed in the project.
Yeah, and then when we move from markets to a lower level, we also coordinate at the level of system services and harmonized products. So on the figure below, you can see the 2 types of products where we have defined harmonized products. So you have the non-locational products and the locational products. And for the non-locational products, there we have defined 6 different products of which you will probably at least, if you're familiar with the European system, you will recognize the balancing products FCR, AFR, MFR, and RR. And then on the right-hand side, we have defined locational products. Here we also have 6 products, and they differ whether they are active or reactive products, whether they are short-term or short-term or long-term products, and whether they are corrective or predictive products. Next slide, please.
In this slide, we want to show you at what level the coordination or the optimization of the resources takes place in the OneNet project. In this slide, we mapped the OneNet demonstrators, the market architecture of the OneNet demonstrators, considering the coordination schemes. And the axis, in particular, the vertical axis represent the TSO-DSO interaction level. So it means that the coordinations that are happening, like in the common market model, are stronger. And well, I need also to introduce the definition of the common, multi-level, and fragmented market model. In common market model, we have a single market in which the TSO and the DSO are both buyers of the resources that are available. In the multi-level market model, these buyers act in a separated market, but these markets are not independent. While in the fragmented market, in the fragmented market model, we have that these markets are also independent. So we see that in OneNet, we have a lot of variety of market models, and also a lot of variety in terms of how the coordination takes place. We see that in common and multi-level market model, we have both the market-based and the technical-based coordination of TSO and DSO, while in the fragmented market model, we see only the technical-based coordination. So in common and multi-level market model, the coordination takes place both at distribution and at transmission level, while in the fragmented market model, we have only one of the two levels. And we want also to remark that in OneNet, we have also coordination that takes place between actors that come from different countries, because we are demonstrating flexibility markets that cover more than one country. Okay, and in this slide, we want to show you how the access to the resources is organized in OneNet project. In particular, we have two different, we have the central and local needs that has to be satisfied. And we have two schemes of coordination that are used for solving these needs. And in the case of central and local needs, that are needs of the TSO and of the DSO, and that they are covered in using different markets. We have that when we have the common market model, so we have a single market, the access to the resources is granted to both the TSO and the DSO, and they have to share the same pool of resources. While when we have separated market, so the TSO and the DSO have both access to the resources, but they don't need to compete in the same market for these resources. While when we have a local market, in OneNet, only the DSO is the one that has the access to the resources, while the TSO cannot access to them.
Okay, and then we come to the next question. How is the market design realized within the project? So one of the objectives of the market design work package in the project was to design efficient, scalable, and integrated markets. And when we started this task, we first looked at the previous project, so see what was done there, for instance, like CoordiNet, and we saw that between the project there was not these different projects there was not really a general similar type of approach. So that's why we developed this theoretical market framework. And this framework focuses on system services for TSOs and DSOs, and also only on market-based mechanisms to acquire flexibility. So we do not look at dynamic tariffs, for instance. The objective of this framework is twofold. First of all, it is a descriptive tool, meaning that we use it to describe the already existing markets for system services. But it is also, and that's the second objective, it is a prescriptive tool. So we can also use it to develop novel markets and also see how these markets ideally should be integrated with already existing electricity markets. And then the framework itself, it consists of 5 different pillars. And the first 2 pillars, they are the entire market architecture and the sub-market coordination. So these really focus on the architecture of the market, consisting of different sub-markets, and also how coordination between these different sub-markets is organized. And then the next 3 pillars, market optimization, market operation, and grid constraints representation, they focus really on how the clearing of the market takes place. And so we have described this framework, and we have also then used it for the demos to describe the markets that the demos are setting up. And we will also use it as a basis for further work in the work package. For instance, we are currently working on the task to look at what the challenges are of integrated markets. Next slide, please.
Okay, in this slide, we show the results of the application of the theoretical market framework to the market architecture that has been proposed in OneNet. So at the end, the theoretical market frameworks allow to describe the entire market architecture, and the description of the market architecture relies on 2 elements. The first element is the sub-market, so the boxes that are represented in this picture. And the sub-markets describe all the procedures that are necessary for the exchange of the products from the seller to the buyer. And while we identify 2 different types of sub-markets. We have availability sub-market, in which we have capacity products that are exchanged. And then we have activation sub-markets, in which we have energy-based products that are exchanged. The sub-markets are not standalone entities, but they can interact among themselves. And we in the theoretical market framework, we identify 2 kinds of interaction. One interaction is bid forwarding. It means that the unused bid from one market can be used by another sub-market for the clearing process. But also we have the participation forwarding, and this is typical of the interaction that exists between availability market and activation sub-market. So in this picture, in particular, we are showing a multi-level market architecture. So we can distinguish about 2 different layers, the DSO layer and the TSO layer. So the vertical axis in this picture represents the buyer-wise allocation of flexibility. So the market architecture is characterized by these 2 layers, and each of these layers has a different buyers that buys the service to from the providers. But we can also have the description of the common market model. In fact, in that case, as you can see in the following slide, we have the 2 layers, the TSO and the DSO layer, collapse in only 1 layer, and both of them are buyers in the same sub-market. But the functioning of the market architecture can be described in the same fashion. Okay, now we leave the floor to Ferdinando. He will introduce the topic about data exchange in OneNet.
Thank you, Matteo, and thank you, everyone. Good afternoon. So I will explain how the OneNet project addressed the topic of the data exchange and how it is realized in the OneNet project. We focus a lot on the data exchange because one of the main goals of the OneNet project is to create a solution that allows to create a network or platform and a fully decentralized ecosystem for interoperability and data exchange. And this is the IT solution that the OneNet project aims to implement and to provide to all the European energy stakeholders. But not only an IT solution for addressing this topic, but also an analysis of any kind of cross-platform services. And when I mean cross-platform, I mean an integration of services between two different actors, for example, TSO and DSO, or also flexibility provider, in order to cooperate in any kind of services, both for market and network operation. But also we addressed also the topic of the standardization and how the data model standardization can support the data exchange in the OneNet ecosystem. Next slide, please. Okay, so this is the approach that we designed for the IT solution of OneNet project. And as I mentioned before, we aim to have a decentralized ecosystem in which any kind of stakeholder, OneNet participant, can participate easily and integrate its own existing environment in this pan-European ecosystem for the market and network operation. In the left side, you can see the logical perspective of the IT solution. So we implemented a OneNet decentralized middleware that allowed the participation of any kind of energy stakeholder as a data provider or data consumer. And the decentralized middleware allowed the integration of any OneNet participants in an easy way, keeping the control on the authorization, authentication mechanism and security layer, and also adding some additional feature for the OneNet participants. But the core of the IT solution that we provide in OneNet, it's the deployment point of view, because the decentralized middleware consists of a OneNet connector that is a decentralized instance of the middleware itself, and it's deployable directly in the OneNet participant environment. So any energy stakeholder can install and deploy its own OneNet connector easily in its own existing environment and participate in the OneNet ecosystem as a data provider or data consumer. And of course, the entire data exchange is completely decentralized. So after the first step of the registration and the discovery of the data source inside the OneNet system, each participant can exchange its own data with the other OneNet participants directly in a peer-to-peer or decentralized approach. Next slide, please. As I mentioned before, we also provided not only an IT solution, but also an analysis of any possible cross-platform services that should be supported and mapped into the OneNet ecosystem. We used an hybrid approach, a mix between top-down and bottom-up, in which we analyzed not only the use cases of the OneNet demonstrator that are already included in the OneNet project, but we also conducted a deeper analysis in the already existing relevant H2020 projects that already addressed this topic, and we made a gap analysis in order to find all the possible cross-platform services categories in which we mapped all the cross-platform services. And at the end of this gap analysis, we found 10 main categories for the cross-platform services and 64 different cross-platform services. But the activities that we conducted not stopped here, but we continuing mapping all the business objects that are, let's say, foreseen in the data exchange in this kind of cross-platform services. And we found for each business object, the standardized data model that could be used for the data exchange during the data exchange process, thanks to the collaboration with the demonstrator of the OneNet project. Next slide, please. The result of this analysis was to identify which kind of relevant standard can be supported in the OneNet ecosystem. And the result is that the FireWire Smart Energy architecture already provides a subset of standardized data models that could be used for the data exchange in the OneNet ecosystem. But we also integrated with other relevant standards, in particular for the market and for the for the distribution management system, the 2 EIC standard. But we are continuing our work in order to find the extension of possible standardized data model or other standard, relevant standard data model that we can use for the mapping of the data exchange. But another need that bring out, let's say, from the analysis is that not all the cross-platform services and not all the use cases that we analyzed use a standardized data model or foresee to use standardized data model. So even if we support a lot the usage of standardized data model for interoperability of the data exchange, we also support the definition of new data models or the usage of customized data model in the OneNet ecosystem in order to facilitate the data exchange at any level. And I think it's all from my side. Next, please.
Yeah, finally, we just want to show you, if you are interested in our project, you can find the website. And also, if you have more questions regarding, well, specifically targeted at one of us, those are the emails. So yeah, visit the website or contact us. Thanks.
Perfect. Thank you very much for the insights on how the TSO-DSO coordination is performed in OneNet. So you've already been introduced to Redispatch 2.0. So now we are getting insights on how the future, namely Redispatch 3.0 can look like. So now I would like to hand over to Jirapa, who will present the Redispatch 3.0.
So thank you so much for having me today. Good afternoon, everyone. My name is Jirapa Kamsamrong. I am a group manager of smart grid testing at Office Institute based in Oldenburg, Germany. But today I represent Redispatch 3.0 project. And as we hear already from Julia from the project and Redispatch 2.0 development, here I will share what we aim to develop further from Redispatch 2.0 project, and to improve TSO and DSO communication for the congestion management in the Germany context. And yes, we hope that our research project can be applied in any context in the future. Next slide, please. So TSO-DSO coordinations, and yes, as we have more and more distributed energy resource at medium and low voltage levels, therefore, we need an effective and close to real-time communication for better congestion management. As you can see on the left-hand side, Redispatch 1.0 in the past, TSO and field actors, such operation and balancing manager, only involved for the congestion management. And these only include the power plant with capacity of more than 10 megawatt. And until last year in October, and we have the new Redispatch 2.0 that enforce all network operator, including DSO, at medium and low voltage level for the congestion management as well. And this also tapping on the system lower than 100 kilowatt that can be remotely controlled by network operators. As you can see here, that all actors and power plant units across the network must involve in the congestion management. And the challenge lies that how can we communicate between TSO and DSO? And of course, new requirement of the IT solution, information exchange, and effective coordination that we need to tackle in the futures. Next slide, please. So basically, for the network operator coordination concept, normally the communication between TSO and DSO is a hierarchy manner from TSO and to the DSO that under their control area. And then they will coordinate for the suitable measure to solve the congestion management. And however, the information exchange is not only during the Cascade event, but also the entire process. For example, like before, during, and after the Cascades. So this communication exchange can be done either one way communication, for example, low priority that they need to send the data to informing them. And of course, two-way communications for the critical event that may lead to the blackout or large-scale emergency, event later on. So in such kind of the critical event that we don't want to have, And we would like to develop some kind of the IT solution, online data exchange that's close to real-time communication. That's really important for the congestion management in the futures. So that is the technical challenge that we want to tackle for the further development of the Redispatch in Germany. Next slide, please. So here, to tackle of those technical challenges that I mentioned from the previous slide, so Redispatch 3.0 project, we aim to improve information exchange between network operators by further develop what we already have done and already implementation right now of the Redispatch 2.0. And in this project, we really focus on small flexibility potential behind intelligent measurement system. After solving those congestion management, and of course, there's an untapped flexibility behind that we can use. Our project had just started this year in January, and we plan to have 5 phases of the working package. The first one aimed to derive some kind of the use case, what is the meaningful, and what is the technical issue that we have to tap on. And of course, the relevant actor that we need to taking into considerations, or those also the smart meter gateway and controllable local system, or we call CSS in Germany. The second phase, later on when we have the use case, we're trying to derive some kind of the prototype that we can test in the laboratories in the phase 3. So in this phase, we would like to have a look closely for the cascade communication between TSO and DSO. And of course, when we're talking about real-time communication, we would like to tackle and investigate very close to the cloud-based SCADA system that it can exchange the data information across network operators. From this phase, we expect to identify the possible solution that we can improve the Redispatch 2.0 that we already implement in Germany, and to make it better, faster, and secure information exchange. And later on, we will use the result from the test environment to be implemented in the field test. And of course, we have 2 field tests that have different geographically. One is represent the rural area, another one represent an urban area. And of course, the result will be analyzed for the post-marketing. As I mentioned about the untapped flexibility. So with this kind of thing, we have the incentive model that we are going to look for, and have the intelligent agent that to make the decision process later on. So this is the overall Redispatch 3.0 that we would like to aim until the end of 2024. Next slide, please. So to capture about real-time cascade coordination interface that I already mentioned. So cloud-based SCADA system, will be exploring these projects for real-time cascade coordination between voltage level. For the congestion management and automatic and real-time communication are really important across all network level that we really need enough time to react the redispatch measures. Therefore, cloud-based SCADA is expected to have those kind of resilient and secure communications during normal and abnormal events. As a result, our network operator will have enough time, to prepare, react, or those events to prevent the large-scale cascade failure. In our project, we also explore the flexibility outside of the SCADA as well. And of course, it can connect to the prosumer behind intelligent measurement system. We use CLS management that external markets such as aggregator can connect to the SCADA system, and of course, all that small flexibility behind the metering system can participate into the market. And as a result, yes, unused unflexibility after the cascade can participate in energy market later on. Next slide, please. So here is a plan that we try to capture all the untapped flexibility potential. Normally, when the congestion happens at any location, redispatch measure will be activated, such as battery energy storage, load shedding, demand response with the incentive response. And of course, those untapped flexibility or unused one are left behind in the system. And this potential is very attractive technically and economically. And our project would like to evaluate this potential behind the measurement system. And of course, these come with incentive models, intelligent agent that will make the best decision for participating in the market. We're expecting that like this untapped flexibility can be used, and of course, not only in the energy market, but also can be prepared for the next congestion management event as well. Next slide, please. So to capture all the relevant aspects for the further development of Redispatch 3.0 in Germany, our project consortium consists of relevant parties such as TSO, DSOs, research institute, and company, as well as standardized organization. At the end, we aim to suggest the improvement of the current Redispatch procedure for secure and faster communication in the future. And the lesson learned, we hope that we can share with other countries that can be applied later on in their context. Next slide, please. So yes, as I mentioned that our project has just started, and if you have any suggestion, question, feel free to send me the email. We will be happy to get in touch with you. And thank you so much for your attention. And I'm happy to answer the question that you may have at Q&A session later on. Thank you.
And thank you very much for the insights. Now, last but not least, we're heading over to an international project again, which is CoordiNet. So I would like to hand over to Yvonne Ruwaida, who is presenting CoordiNet.
I'm Yvonne Ruwaida. I work at Vattenfall distribution. I'm work package leader of the Swedish demonstration in CoordiNet that works with TSO-DSO-Consumer, large-scale demonstrations of innovative grid services through demand response, storage, and small-scale generation. Next slide. So in the Swedish demonstration, the need for coordination is between the regional DSO and the TSO. So it's congestion between those two levels. The coordination is also between resources in the DSO grid purchased by the DSO, then forwarded as bids to the MFRR market purchased by the TSO. And we do solve the issues market-based. We work with day ahead, intraday, both with free bids, energy, and availability purchase, capacity purchased weekly, seasonal, or perennial. The flexibility service providers participating in open, non-discriminatory calls have been industries with heat pumps, heating companies, batteries, or customers or independent aggregators for resources from different customers, for example, heat pumps and e-mobility. And we have not only in Sweden, we have different markets. You see in the page here, but we also have new markets that have been inspired by CoordiNet, both in two other regions. Next page. The access to the product, the source, is through a central and local market, where the buyer is the DSO and the TSO. We have more than 3 markets. And on these markets, you have then access to aggregators that are independent or customers. You also have peer-to-peer markets in 2 places, where producers purchase production or consumption from their peers. Next slide. So how does the coordination optimization take place? We have a time coordination. The DSO acts preventively on a forecast day ahead before the day ahead spot market. and then also acts on a revised forecast or operational situation after day ahead, but before the intraday spot markets. The unused bids are forwarded to the MFRR market, and the coordination with FCR and AFRR has also been made by customers and has made it possible for smaller actors to participate on the TSO market. The independent aggregators are optimizing resources to different markets, like you see on the picture here. It can be the local flexibility market, the wholesale market, or the balancing markets. And they also optimize against customer subscription. And these are independent aggregators participating in open calls on this market. Next slide. The CoordiNet market timings, I think the time coordination is one of the most important learnings, how important it is. And in the Swedish demonstration, the DSO is purchasing before the wholesale markets, day ahead and intraday. In the Spanish and Greek demonstrations, we have had the DSO purchasing after the wholesale markets. Next page. In the CoordiNet, the local DSO and the regional DSO can be buyers. And the regional DSO has been acting market operator in a market-based way. In Stockholm Flex, that started the course and inspired by CoordiNet, the market operator is an independent actor, and this is Notes. So the most important things here is the market platform that can be provided by the DSO or by an independent market. And then you have the Flex tool, and the Flex tool is needed for the DSO to be able to purchase dependent on the need in the grid. The market platform is also the actor who is forwarding the unused bids to the MFRR market. Next slide. There's a lot of data exchange between these different actors, and these are described in this picture. You have a lot of information to be able to make a forecast. So the forecasting service provider, that can be the DSO or that can be an independent party, needs production plans from significant grid users, measurement data. They also need old historical measurement data to be able to understand. And of course, also they have information on weather and other prices and other information that is important. So the forecast is important in this model where you work more preventive and not only act in the operating time. And then you have all the other information, for example, reference line to be able to make a validation. It's also called baseline sometimes. And you need the sell orders, you need the buy orders, and of course the confirmation information. In Sweden, you also need some dialogue and coordination with the TSO on the subscription, because in Sweden it's possible to purchase subscription temporary for each hour. So this kind of coordination is also needed. The next slide. So, and in the Swedish demonstration that has been working for 3 winter seasons in open calls, you have other DSOs, E.ON Energidistribution, and the TSO participating. You have forecast providers like Expectra, RTO Aachen, and also the city of Uppsala, who's been working with recruiting flexibility service providers, together with Vattenfall el distribution. And the market platform and flex tool provider has been E.ON Energidistribution. So thank you very much.
Okay, thank you, Yvonne. I think we reached the hour. Thank you all the speakers. Sorry, I'm going to put my camera. We also had So we answered the question. I think we can take a couple of more. I know that Julia, thanks a lot for answering already some questions. We have one question from Esteban, says that if we engage customers to change the time they use the appliances partially in response to variable renewable output, we analyze the basis of existing top-down forecasting. Have you looked at that and the impact on heat and EV demands? I think this is general to imagine to any of the projects. I don't know who, someone who wants to answer to this one. Julia or?
Yeah, I saw the question, but yeah, the heat and EV demands are not yeah, part of the Redispatch 2.0 processes. So yeah, from the perspective of Dare, unfortunately I cannot answer to the question.
Okay, Jirapa, are you planning to include these resources in the Redispatch 3.0?
Hello. Yes, we will tackle of those as well. But yeah, that is something like we would like to explore, you know, to the congestion management in Germany. So yeah.
Okay, and when do you expect to have some results from that?
I think after this year, we will have some kind of like you know, high level architecture and framework that we would like to tackle with that. So maybe next year we can have another webinar to share the result later on. Yeah. Okay.
Perfect. Thank you. I think Hans Peter, sorry for pronunciation, Schweffel, made a good question here. I want, although Julia answered it, I think could be relevant for other projects. Can you please elaborate what type of constraints and optimization targets the selection of the generation units can be taken into account when using the system, let's say in general, and everyone that wants to, does it consider loading lines, voltage bounds, medium, low voltage, high voltage networks? Whoever wants to answer this one, I think, well, it was for the first speaker, but I think it could be also answered by any of the panelists.
Yeah, I could answer what I have written already, or is it not sensible to repeat it because everyone can read it? Okay, no, it's okay, Julia. Then I got here because it went to answer questions also. Okay, Ferdinando also reply. Yeah, Fernando, I don't know if you want to answer. You mentioned the mapping of products and services in OneNet and other demos. Could you consider that 10x platform service categories and 60x platform services are now kind of reference capitaling all previous related projects? And this is a question from Atanas from the Well Innovation.
Yes, thank you for the question. I already tried to answer. Let's say yes, because we have done a very huge work in order to analyze all the other projects and also the use case of the OneNet demos. Consider that we have 4 clusters and 12 countries and demos inside OneNet, so a lot of information. We are collecting, we are finishing the work of mapping the business objects and the data models at the moment. And at the end of the work, we foresee to have this kind of repository in which we will publish our result and disseminating our work in order to create this kind of reference with a list of categories and cross-platform services and business objects. to be extended. Yes.
Thank you, Ferdinando. Maybe Yvonne, because I think this one I think is relevant for CoordiNet, and so there was a question made by Stefan Browning. If we engage customers to change their time to use their appliances, partially in response to variable renewables output on the basis of the existing top-down forecasting, have you looked at the end at the impact on heat or EV demands in your experience of CoordiNet?
I mean, things are happening while we're having the CoordiNet project. And I would say that one of the biggest insights is that we actually have to get tools to be able to address the changing behavior of customers. And I would say that customers are changing behavior because partly some customers are becoming prosumers. So they're both having production and consumption. Some customers are participating on different markets, either themselves or aggregated. So actually things are changing in the grid, and working with flexibility as well as market-based and rule-based, I think is very important to be able to manage with this change. And for example, some of the new actors like EV charging and heating pumps are also suitable to be able to be flexible in a way that is different from traditional customers. So I think that's my comments a little bit. But I think believing that purchasing flexibility in itself is of course, it is a challenge with the energy system changing, but it is changing, that is a fact. So we have to address the challenges.
Okay. Thank you, Yvonne. And here, maybe the last question that was previously answered for Sultan Marik, which is, has any conversation regarding changing the wholesale energy market mechanisms so that trades include the cost of complexity of delivering energy? For example, by using nodal instead of flat countrywide energy pricing, and Julia already replied, but surely this could be relevant for other projects. And also Sultan also put the reference to the recent discussion in the UK about nodal pricing implementation. Any thought from?
No, I think the issue of nodal pricing is interesting, because I do think that what we have been doing a little bit in CoordiNet is having additional price signal upon the wholesale market that is reflecting congestion. So in a way, it's a complementary nodal pricing on the copper plate, you could say. So in a way, that's actually what these kind of combined central and local markets are doing.
Yeah, Yvonne, thank you. Of course, this debate, just to answer personally, has been in Europe for a long time. There are some discussions on it. I imagine the implementation and changing the current energy system or market design into a nodal system requires like big agreement among different partners and the countries. But definitely this is under current debate, I believe. I don't know if someone from Germany wants to add on this. Jirapa, to what extent Redispatch 3.0 will have this as a reference? Or
you mean about the pricing?
Yeah, nodal pricing.
Yeah, in our projects, we try to develop the incentive models. And of course, we are going to have the intelligent agent using AI. And yeah, for the small flexibility behind of the COS management system or smart meter gateway. And that is something we would like to tackle on because we really see this potential is very attractive. And of course, it had not been implemented yet in the energy market. So that is something we would like to figure it out, what type of incentive model that would appropriate for these small flexibilities and how it can participate in energy market in Germany. So yeah, that is yeah the expectation that we would like to list at the end. And of course, there are more issue on the energy market mechanism in Germany. So we hope that if the result is promising, so we would to recommend some kind of the policy recommendation at the higher level later on. So yeah.
Okay, thank you. Perfect. We will follow up on this. Very interesting. And just last question. I know that we really are out of time, but Yvonne, if you are still there, first, Stefan, thanks for your answer. But the answer is asking if some of the heat pumps and EVs resources for system services do you have a requirement to meter all the installations to support accuracy of demand forecasting?
We have actually a requirement that all the significant grid users, and they are resources bigger than 1.5 megawatt, we want to have the right to be able to have their production plans. And I mean, now we've been doing this on the higher voltage levels, but if you go down on even the lower voltage levels, I do think some kind of information on the forecast of the production and consumption from the customers themselves could be a good thing to have, to be able to understand what's happening if you want to act more than only in the operating hour. So it's actually depending on how the market design will look like. The more the market design demands that we work before the operating hour, the more you are dependent on information.
Okay, thank you very much, Yvonne. So with this, just want to thank you all for your participation. I'm putting in the chat. No, sorry, I didn't put to everyone here. Yeah, the link to our ISGAN Virtual Learning YouTube channel. So where this webinar will be also available, and hope you all can subscribe to our next webinars, which I think I put here the information also. So thank you all, and very interesting projects. And I think this really brings the next steps on market design in Europe in this case, but I think relevant for worldwide audience. Thank you all.